Well, here's the very last part of the nuclear balance chemical reactions. This is just the add-on for this year. So I'm going to turn this paper over, parts 1 and 2. Got the rest of the questions. And we're just going to focus here today, or at least on this video, on the naming, how to name these elements. So that's number 23 and 24. So let's see. First off, naming the compounds. This is almost as easy as looking at your periodic table and finding out B is for boron. The metals, or in some cases, like over here, if it's a polyatomic ion, you write them first. So you got boron. Now, Cl is chlorine. Now, what you do need to know is that chlorine is going to be chloride. When we do these, we practice that. Boron chloride. And if that isn't obvious to you, on a chart of atomic ions, when you find chlorine, it's going to be in the form of, where are we? There you are, chloride. And it can tell you that there. Now, there are 3 chlorines here. So it is possible, we zoom in here, make it a little easier to see. So we could say, hey, this is boron trichloride. Okay, because there's 3 of them. And if we really wanted to be super specific, we could say, well, there's only 1 boron, so we're going to call it mono, which means 1 boron trichloride. Well, that may or may not be on the test, but the simplest answer for this one is boron chloride. If you had a choice on this one that you had boron trichloride, well, that's more precise. Go with the more precise one. K is our friend potassium. So you look on the chart. N is nitrogen. Now we always end the nonmetals in "ide", so it's not nitrogenide, but it's nitride. So nitride. I don't know if our polyatomic ion chart is going to have nitro. Oh, it does. I look at there. N nitride. So it's on the chart to look at. Now, like I said, if we wanted to be real specific, this could be tripotassium mononitride. Okay, more than likely it'll be potassium nitride, but these are more specific. Now for something like this, we've got 2 elements there. You just say the names of the first 2. Sodium and then hydrogen. So this one's name would be sodium. Oh, I left out the I. Sodium, hydrogen, J-E-N. Sodium, hydrogen. Now, CO3. Now, that is actually a polyatomic ion. And you can look on a chart. You can look in it, but right here, let's see. Ions. There we go. Carbonate. CO3 is called carbonate. And it's got a -2 charge, but we don't need to know that now. So, sodium, hydrogen, carbonate. Now, we could say monosodium, monohydrogen, monocarbonate, but probably we won't do that. Now, this one over here, we've got a compound that's 2 polyatomic ions. So, NH4, so you look on your chart of polyatomic ions until you find NH4. Okay, we got to look. And, okay, since this is the first one written, it's going to be a plus charge because you always put, if you don't have a metal to put here, you put the plus charge ion or polyatomic ion. And coming over here, let's see, where is ammonium? There we go, NH4 with a plus charge. That's ammonium, so that's its name. You just have to look that up, ammonium. It's a form of ammonia. So you got ammonium. And then SO4. Now that's going to be a minus charged particle. Actually, when we looked up this one, we said that one had a -1 charge. Now, since there's 2 of those, that means that this sulfate would have to have a -2 charge. So if I just come to my chart here of -2 ions, sulfate, SO4, there we go. So SO4 is sulfate, A-T-E. Be careful, not sulfide or sulfite, sulfate. S-U-L-F-A-T-E. Let me make sure I get the right one. There we go. So ammonium sulfate. And hey, maybe if we're going to be even more specific, we might say, since there's 2 of them, diammonium. It might even, sometimes they might even throw in the other prefix for 2, bi, okay, but that could happen. Now, coming down to number 24. Now, this is just the reverse. We're giving you the name of the element, and you got to tell us what it's made out of. Well, chromium, when you look on the periodic table, and that might be the hardest part of this, is finding wherever chromium is. Oh, there it is, Cr. So it's going to be chromium. And what's nice, when you see the Roman numeral, that's telling you the oxidation number, which is also the ionic charge, plus 3. Then we've got chloride, Cl. Now, by this time, you should really know that any element that's a halogen, when it gains 1 electron to be stable, it's going to have a -1 charge. But if you still haven't got that yet, you can look on this chart to find chloride, and it's got a -1 charge. -1. Now you do crisscross. You crisscross the numbers here. We want the absolute value. So this becomes chromium. We don't bother to write a 1. Cl3. So that's how you'd write chromium 3 chloride. That would be its formula. So for this one, copper, there we go. Cu, cupric in Latin. So we got Cu, thank you very much. It's copper 2 plus 2 oxidation number. We already know that chlorine's got a minus number, so every chlorine is a -1, every chloride, excuse me. Well, we do crisscross of the absolute values of their oxidation numbers, also known as their ionic charges, and we get Cu1, Cl2. There we go. We use that in our lab. This was the stuff that when you added it to ammonia, it went and dissolved and ate itself. Lithium. That's what powers the Starship Enterprise from Star Trek, at least dilithium crystals, but lithium is Li. And lithium is in group 1. All of these elements lose 1 electron to become stable, so they have a +1 charge. If you don't remember that, you just have to hunt on here until you, there we go, lithium +1 charge. Carbonate. Well, we talked about our friend carbonate right up here. Oh, there we go. That's carbonate, CO3. You could also, though, look on the chart. Carbonate is right there, CO3 with a -2 charge. So CO3, I'm going to go ahead and just put this in parentheses with a -2 charge. That's just to remind us that all of that is has a -2 charge. Now we do crisscross. The absolute values of the oxidation numbers come over here, and that becomes Li2, and then CO3, and we just need one of those. Normally we would not put parentheses around when there's just one, but if it helps you get it. So the idea here is this carbonate has a -2 charge, so it's going to take 2 plus charges from the lithium to counterbalance that, because compounds need to end up being neutral. So even though this carbonate has a -2 charge and these 2 lithiums each have a +1 charge, altogether they're neutral. Lastly, lead. Romans called it plumbium. There it is. Pb. Oxidation number is 4. Thank you, +4. And then oxide, well, that's going to be oxygen, but if your oxygen is in this group right here, it would take 2 electrons to stabilize oxygen, which means it's going to have a -2 charge. If you don't remember that, then you just have to hunt on the chart until you find oxide -2 charge. Now we do crisscross of the absolute values of their oxidation numbers, and we're going to get Pb, now 2O4. But wait, both of those numbers are divisible by 2. So we've got to reduce those, because so when we reduce, 2 divided by 2 becomes Pb just 1. 4 divided by 2, PbO. So you got to be careful, because on the test, there will probably be a distractor answer like this. But you've got to know if those two can be reduced evenly, you need to do so. So there you go. I'm not going to say good luck to you, because luck favors the well-prepared.